Alright, welcome everybody. Another edition of Algebra 2. I'm Mr. A. Welcome aboard. We're in Chapter 3 now, Section 1 actually today, and we're going to be talking about graphing systems of equations. Okay, so that's what's on the plate for today. Alright, so first of all, let's look at our objective for today, which is solve systems of linear equations by graphing. That's all we're going to try to do today. Alright, first of all, what's a system of equations? All it is really two or more equations with the same variables. And we want to see what the solution is, and the solution really is just the ordered pair that makes all of the equations true. And of course, we're going to be talking about two usually here. So we're looking for an ordered pair that makes both of the equations true at the same time. Alright, so first of all, how are we going to do this? Here are the steps. Okay, pretty simple. First of all, just get each equation into slope-intercept form. If you remember, that's y equals mx plus b. Let's see if you don't remember, y equals mx plus b. Okay, so we want to get into that form. Number two, just graph each line. And then number three, we just want to see where those two lines cross. The point that they cross, that's the solution. That's all we have to do. So graph the two lines on the same coordinate plane, see where the two lines cross, that's your solution. That's all we're doing. All right, we're going to look at some examples. Example number one, here we have two equations. What would I do first on the first one to get that into y equals mx plus b form? Subtract x, right? So I'm going to see if I can't fit it in here to the side. I'm going to subtract x on both sides. So the minus x and x cross out, and what I have is y equals negative x plus 3. Notice I wrote this negative x first and the 3 second because that's the order we normally see our equation in, because it's y equals mx plus b. If I wrote 3 minus x, I can still do that, but it's just more chance that you're going to make a mistake when you go to graph this. So I would highly suggest putting x first. Alright, and then the second one, I need to get y by itself, so I'm going to this time add 2x. Add 2x. So these cancel this time. And what do I have left over here? Y equals 2x minus 6. So those are the two equations that I'm going to graph. All right. So remember, in y equals mx plus b, in the formula here, b is where we begin. Remember, which is the y-intercept. Okay. So we're going to begin with b. So this first one here, we're going to go up to 1, 2, 3 on the y because it's the y-intercept. And the slope, which is m, that's how we move. Okay, which is the slope. Alright, so how do we move on this one? Well, it's a negative in front of the x. What does that mean? It's really a negative 1. And if it's not a fraction already, we think of it as whatever that number is over 1. So in this case, negative 1 over 1. So from here I go down 1 over 1. Down 1 over 1. I do a few of these. Or I could go up 1, and 1 to the left is actually this part of the same line there. And I'm going to try to best I can here. Draw a line through all that. You get the idea. Alright, then the other one, I'm going to change colors here. Let's go with red. I'm going to begin with a negative 6. So 1, 2, 3, 4, 5, 6. And the slope is 2 over 1. So I'm going to go up 1, 2 over 1. Up 1, 2 over 1. Up 1, 1, 2 over 1. Up 1, 2 over 1. So here's this line. Ugh. Sorry about the lines today, guys. Well, anyway, so here's the point, though, is look at where they cross. If I would have drawn these lines well, you'd see that they cross right here, this spot right there. And you say, well, what is that point? It's the point of where x is 1, 2, 3, and y is 0. So our solution is 3, 0. That's our solution, is 3, 0. That one point where x is 3 and y is 0, that's our solution because that's where the two lines cross. Okay? Getting a feel for it? Let's look at another one. Okay. Top one, we have to get into y equals mx plus b. So first step, let's subtract x. These cancel. Now here's the thing. When you take x away, that's still a negative in front of the 2y there. So this counts as a negative 2y still, and that equals negative x. It'd be like negative x plus 0. We can drop the 0 part. And then divide by negative 2. So we have y equals, what's a negative divided by a negative? Positive. So that's a positive 1/2 x is what we've got. So that means, where do I begin? There's no number here. If there's no number, you begin at 0. And then the slope is up 1 over 2. So we have a few of those. Or you can go down 1 and 2 to the left. Okay, I'm going to a little better line there. So there's our line for that one. Okay? Second line. Let's change colors. How about, what'd you say? Green? Oh, okay, green. Wow, that's a weird color. Okay, so we're going to subtract x. It's like Christmas here. So now I have y equals negative x plus 6. So where do I begin? Begin at 6. 1, 2, 3, 4, 5, 6. Right there. And then we go with, remember, negative in front of x there. It's a down 1 and 1 to the right. Down 1 and 1 to the right. And so it's going to look like this. And you go, aha. Let me see. Let me try to draw this one here. I'm not good with that, going that direction. Usually. Not bad. So that's where that line goes. Where do they cross? They cross at, where am I? They cross at this spot right here, which is 1, 2, 3, 4 for x and 2 for y. So our solution is the point of 4, 2. Christmas. Okay? Getting the hang of it? How about this one? All right, we got seems like a number of things there we've got to take care of. First of all, let's get y by itself. So I'm going to subtract 9x. Subtract 9x. So these cancel. There's still a negative in front of that 6 there. So negative 6y equals negative 9x minus 6. Divide by negative 6. And so you end up with y equals negative divided by negative, positive, and 9 over 6 both can be divided by 3, so you're going to have 3 over 2x, and then this is just going to divide out to be plus 1. Okay? Where do we begin? We begin at 1. Where's my pen? Here it is. Begin at 1. Go up 1, 2, 3 over 2. 1, 2, 3 over 2. I can also go down 1, 2, 3 and to the left 2. Down 1, 2, 3 to the left 2. All right, so here's our line. Something like this. Oh, yeah. All right, let's look at the other one. All right, this time, what color do you want to go to? Did I hear purple? Kind of a weird purple there. I don't know what that is. Maybe one of you girls will know. But it's minus, excuse me, minus 6x. So that's negative 4y equals a negative 6x minus 4. Divide by negative 4. So what do we end up with here when we divide? We end up with y, I'm going to try to squeeze it in right here, y equals negative divided by negative is a positive. 6 divided by 4 can be reduced to 3 halves. 3 half x plus 1. That looks kind of familiar. Look, it's the same thing we got down here. So our other line is exactly the same line. It's right on top of this. So our two lines are right on top of that. What does that mean? Well, remember before, where they crossed, that one spot was the solution, but now how many places does it cross? It crosses in a whole bunch of places. As a matter of fact, it's an infinite amount. So what we would say, because both lines keep going both directions, so what we would say for a solution here is we would call this infinitely many solutions. Okay? So if you get the same line, it's infinitely many solutions because it crosses in a whole bunch of different places. All right, how about this one? What's the first thing to do? Subtract 15x, just like we did before. These cancel. What do I have now? I have negative 6y equals negative 15x. Notice there's a 0 there. We don't have to write the plus 0. Divide by negative 6. So we have y equals negative divided by negative is positive. 15 over 6, they both can be divided by 3. So that means we have, what, 5 over 2 x, or 5 halves x. Where do we begin when we graph this? We begin at 0 because there's no number out here for b. So begin at 0. And we go up 1, 2, 3, 4, 5, 1, 2 over. And down 1, 2, 3, 4, 5, 1, 2 to the left. Getting better at the lines. All right, that's our first one. Change colors. All right. Let's see. Let's go with, I don't know, how about a light blue? Let's see how that works out. So what do I do here? Minus 5x. Minus 5x. So we have a negative 2y equals negative 5x plus 10 divided by a negative 2. And so what do we have? Y equals negative divided by negative is positive 5 halves x. 10 divided by negative 2 is minus 5. Now, you might notice there's something kind of familiar here. Look at 5 halves, same slope, but the y-intercept is different. How's this one going to look? Well, we have to start with this one at a negative 5. So 1, 2, 3, 4, 5. And then we go up 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. And here's this other line. Oops, I missed some of the line there. It's a parallel line. They're parallel lines. Do they cross? No, parallel lines don't cross. So if the solution is where they cross and they don't cross, what do you think this is going to be? That's right. No solution. Okay? So notice we did a couple there where they crossed in one spot and the solution was just that one point. We did one where the two lines were the same line, so there's infinitely many solutions. And then we did one here where they're parallel lines where there's no solution. Okay? So that's kind of some of the different possibilities that could happen. Now, there's one little twist on this, not very hard, but there's one little twist on this, and they call it classifying these systems of equations. So here's a little kind of overview. These were some of the things that we had just done, but they have some special words for them, okay? So notice the first kind that we did, we had them where they cross like this in one spot. And as we found out, that had one solution. And that's when they were intersecting. They had one solution. Well, whenever you have a situation like this, they call that, you can see up on the top here, they call it consistent and independent. Okay, that's if it's crossing like the first couple we did. This second one, you notice this is where it's the same line, and that's where we have infinitely many solutions. That was the third one that we did. That's called consistent and dependent. And then the third type that we did there, where they were parallel lines and we said there was no solution, they call those inconsistent. It's a little bit harder to kind of remember the words, but here's what I think. Think about parallel lines. I think it's kind of easiest to remember this one because you think if they're parallel lines, they're inconsistent. That means, you know, if you talk to somebody and you say, oh, their story was inconsistent, it means the story didn't line up. You know, it didn't match up. So to me, that's easy to remember. The inconsistent just means parallel lines. That's not too bad. The harder part is remembering the other one. Well, just remember here, if you have something that's consistent, all that means is it crosses somehow. It's either going to cross in one spot or in many spots. That's the opposite of inconsistent. It means it doesn't, you know, line up or it doesn't match up. So the independent and the dependent is really the one to remember. So think about when it's consistent and independent. Here's how I think about it. This may not help you, but maybe. You've got two lines like this. If I move one of these lines independently, I can still have the same solution because I can move this line kind of with the point that it moves, where the point that it moves is like right here where they come together. So if I move one like that, I can move it independently and still have the same solution. Or I can move the other one independently and still have the same solution. But if it's consistent and dependent, the two lines are the same line like this now, can I move one of them and still have the same solution? If I move one by itself, suddenly they're not infinitely many solutions anymore, are there? So in order for them to keep the same solution, I have to move them together. They're dependent on each other. Okay, so that's how I think about it. But let's take a look at a few examples there. Now, what I would highly suggest here as well, there's a little shortcut, okay? And I kind of alluded to it when we were graphing the other ones. You don't necessarily have to graph both of these to see how this turns out. All you have to do really is just put both of these into y equals mx plus b. Again, now you don't have to graph them, but you have to get them into that form and look at them. So let's see what we got here. Minus x, we end up with y equals a negative x plus 5. That's the top one. Okay? Drew, I heard you say change colors. Okay, so I'm going to do it. So let's go to like orange, since it's like fall. Okay. And here to get y by itself, I want to do plus 5. So now on this one, I have y equals 2x plus 5. Now, I don't actually have to go and graph these, but just look at them, and there's really only two things that I have to pay attention to. Look at the slope, look at the y-intercept. First of all, the slope. Is the slope the same? Nope, it's not the same. So that means if it's not the same, it's automatically consistent and independent. Because when you have consistent and dependent, when it's the same line, they're going to have the same slope. Or if it's consistent, well, it's not ever going to be just consistent. The other choice would be inconsistent, and that would be the same slope as well. Okay, so in this case, A is the answer. So when the slopes are not the same, it's consistent and independent. Let's look at the next one. All right, y equals mx plus b. Minus x. So y equals negative x plus 3. And then when we change this here, I don't know, I'm running out of different ones. I don't think yellow is going to be good. And then here we're going to go minus 6. So then I have a negative 2y equals 2x minus 6 divided by negative 2. So what do I end up with on this one? I end up with y equals negative x plus 3. Look at the slopes. Are they the same? Negative 1 and a negative 1, they are the same. So that means it is not consistent and independent. That means it's either inconsistent or consistent and dependent. How do I tell which one? Now look at the y-intercept. 3 and 3, it's the same. If they have the same y-intercept, that means it's the same line, which would be inconsistent, or C. Or what did I say? I'm sorry. The same y-intercept means it's the same line, which is consistent and dependent. Inconsistent would be if they had different y-intercepts. Okay? And then probably this last one here, you can guess what's going to happen on this one. Y equals 3x plus 2, that's already good. So let's just do this last one here. So I have 2y equals 6x plus 10. Divide by 2. So y equals 3x plus 5. So here you go. Same slope, 3 and 3. And then look at the y-intercept, it's different. 2 and 5, they're different. So that means it's inconsistent, or C. And of course you can see what the graph would look like over here. Okay, I think that's going to do it. Any questions we will talk about in class? Thanks for joining me, and see you next time. Bye.